Good afternoon, everybody. My name is Sarah McCord. I'm an ecologist at the Jornada, and I'm part of the National AIM team. And in preparation for the field season, welcome to the webinar on getting started with DIMA, and then a little bit of an intro into sample designs and implementing your sample design correctly. So just a little bit about the format of this webinar. I have a little bit of a presentation to go through on just an intro to DIMA. And then I'm going to quickly demonstrate some of the new features in DIMA from last year, as well as some of the basics of navigating around DIMA. I'm not going to go all the way through the ins and outs of setting up a database and moving forward with data collection in the office field. If you are interested in that, I'll be sending out a number of DIMA tutorials after this webinar, and at that point, feel free to familiarize yourselves with this webinar. So anyway, after the DIMA demonstration, there'll be a little bit of time for questions about DIMA, and particularly the DIMA homework portion of the AIM training pre-coursework. And after that, we will move into sample designs, and Sarah Burnett will talk a little bit about how to implement an AIM sample design effectively. So before I get started, real quick, a reminder to mute your phone if you're not asking a question, just as that reduces background noise. And also to chat me the number of people and the names of the folks who are in the room with you if you are in a conference room listening to this webinar. All right, so with that, I will get started. DIMA is an access database designed and supported here at the Jornada to improve electronic data capture, which is one of the core principles of AIM. The advantages of using DIMA is that it allows for rapid data entry in the field, which can substantially reduce the cost of data collection. It can also ensure higher quality in your data because you're able to cache errors before they're recorded with some of the built-in error checking functionalities of DIMA. Furthermore, there's options to run reports and evaluate your data right there in the field and to say, okay, 20% bare ground, yes, that makes sense, or no, we must have done something wrong. There's no way there's 20% bare ground on this site. So there's some real advantages to the quality assurance steps. And finally, just with the way that the forms are structured, it really enforces proper implementation of the protocol and making sure that you get all of the measurements that you need to collect. All right, so where do we use DIMA? And hang on just a second. I want to change the screen that I'm sharing. So we use DIMA in the field for data collection, on-the-fly reports, and Q&QC, as I've mentioned. But DIMA is also a really powerful office tool where we can enter data that were collected on paper. We can QC the data that were either collected on paper and entered, or were just collected straight into a tablet in the field. And then we can also run some data summaries and reports that can be useful for resource staff and others who need to make management decisions based on monitoring data. How do we access DIMA? You can access it by downloading the database from the Jornada website. If you just Google Jornada and DIMA, then you'll find this page with instructions on how to download it. Just some notes that there are some troubleshooting tricks that may be required depending on which version of Access you're running. But don't be alarmed, that's completely normal, and move through that and you'll have DIMA up and running in no time. So just a little bit about the structure of DIMA. We have basically 3 different entities that you're working with when you're entering data into a database. The first is a site, and those are highlighted in the green and the blue here. And a site would be some grouping of plots, and it may be spatial, like an allotment, or say the strata from your sample design, or it could be aspatial, which could be like all of the plots that fall within, you know, that had purple flowers on them, we're going to put in this particular site. So it's intended to be a useful organizational tool. If you're curious about the best way to use the site and the best grouping, we're happy to have that conversation, or perhaps your project lead or state lead can assist with that as well. So within sites, we have plots, and plots are the physical location that you go to collect monitoring data. And so for many of you, you will have received plot locations already, and you'll put those in your GPS and then navigate out to the site. And at that point, you'll establish a plot. And a plot is the entire area that you assess, and within that plot, you could have lines or transects, and we treat transects as subsamples as a way of distributing measurements across the sites, but we don't treat those as reporting entities in and of themselves. All right, any questions about the structure of DIMA? Wonderful. So moving on, there's quite a few resources to help you out with DIMA if you have issues or you're not sure what the next step is with DIMA. The Jornada DIMA website has a number of troubleshooting tips, as well as a forum where you can go in and look at questions that have previously been asked or submit a question on your own. The Landscape Toolbox is an excellent resource. That's where all of the DIMA tutorials are hosted. And then finally, the aim.landscapetoolbox.org website has a number of the primary sources for AIM-specific information and AIM-specific DIMA tutorials. And so some of the data management protocol and aspects that apply to DIMA are listed on the AIM website. And finally, please don't hesitate to contact us. Again, myself, Sarah McCord, I'm a good first line of defense. In addition, Erica Courtwright is the database program manager, and so she's also an excellent resource for questions, as well as Nelson Stoffer and Sarah Burnett. So please don't hesitate to reach out. My only encouragement would be that if you're going to reach out to Erica, please also copy myself and or Nelson or Sarah on that email as well, just so we can help Erica deal with the large workload of the emails that she receives. All right, so finally, one of the reasons that you might reach out is because you have errors or some feedback on DIMA, and we really encourage that interaction with DIMA, and one of the wonderful things about DIMA is the interactivity and the quick response time we have to issues and errors. Just as a reminder, folks, to mute your phone if you don't have a question, just so we can avoid background noise. All right, so if you're going to report errors or provide feedback, there's some key things that we need to know. First is what version of DIMA you're using. If you're reporting an error, if you can explain what you were doing prior to the error, and send us a screenshot of the error message. It's really helpful for tracing things back. And as I said, we're really open to suggestions or feedback and trying to make this database the easiest monitoring tool that it can be. All right, so what's up next? We're going to talk about what's new in DIMA in 2017, and then show data entry for several of the core AIM methods before moving on to an introduction to sample design management. All right, so I am going to switch over to DIMA and demo some things there. While I'm pulling up DIMA, are there any questions? Okay, so let's say you've gone to the Jornada website, you've downloaded a database, you've extracted it, and this is going to be the screen that pops up. So this is a blank database. There's no data in here, and now it's up to you to go out and collect monitoring data. So one of the first things that you are going to need to do is set up the database. So DIMA is really flexible. It's really customizable, which is awesome because it means that depending on the project, you can use DIMA for a lot of different things. And we use DIMA for research projects here at the Jornada. There's a group in Mongolia that uses DIMA as the National Program Monitoring Database there, as well as AIM is a large user of DIMA. So how do you go about setting this up? You're going to start with the administrative functions, which is this button right down here. And in administrative functions, there's two aspects of this. There's system setup, which is how you basically choose what data you're going to be able to enter in DIMA and what format that'll take. And then data management allows you to deal with updating plot associations with sites as necessary. And the key one that we often see AIM crews using is the mass update of a species code where you've had an unknown plant and now you know what it is, and so you can update it. So on the system setup side, the first thing you'll want to do is say, what data are we going to collect? A lot of data can be stored in DIMA, but for AIM, we only deal with a subset of those methods. So for AIM, we're looking at canopy gap, so that's gap intercept, line point intercept, soil stability, species richness, and sometimes we see rangeland health and the ESD data entry form checked on. So those are the standard methods that you'll need to do an AIM plot. So once you've selected the methods, there's some additional specifications about how we're going to collect those methods. And those are relative to how long our transect lines are, at what interval do we take measurements, and things like that. So the standard AIM transect length is 25 meters. Although in consultation with your project lead, you do have an opportunity to fix that. So we'll set that to 25 meters. Our spacing interval on a 25-meter transect is every 50 centimeters, and we start at the 0.5, the 50-centimeter mark along the transect. We also collect height in addition to line point intercept. And so we collect height every 5th point, and you can select to say that's okay. And we collected it using the BLM AIM herbaceous and woody heights. Now a note for sage grouse folks, an upcoming update in the next couple of weeks is that we will allow you to collect both grass and forb and split the herbaceous category in two. That'll be a change forthcoming. And then finally, we use the checkbox to note when we hit a standing dead plant. And if we were doing sage grouse monitoring, we might also check the shrub shape box on. So these are the set of defaults that you need for line point intercept in AIM. And this is all described in the tutorial for how to set up a database that's listed on the landscape toolbox. Okay, so I'm going to keep moving pretty quickly. Canopy gap, we only want canopy gap. Soil stability, generally you can leave it as it is. And species richness, all you have to do is select the AIM option, and you're good to go. Okay, now one quick new feature for those of you who have used DIMA in the past. You might note that there's a lot of LPI lower surface code options that we don't use as part of AIM. And so a new feature is to allow you to select only the codes that are mandatory for AIM. And so in that case, for the lower codes, we are only interested in litter, woody litter. Animal matter actually falls under the litter category for AIM, so does dung. Embedded residue is just regular litter for us, or embedded litter. And then you human trash falls under other litter, and so on and so forth. So we actually, you might keep vagrant lichen, but the rest of these get turned off. So this is a nice way of cleaning up the LPI form. And then moving on, you can do the same thing with the soil surface code. So if you're a new crew member and you're going, what is she talking about? Don't worry about this. Chances are that you have a database manager or a project lead who can help you out and make these decisions. I'd also refer you to the monitoring manual. Table 15 describes the codes that we use as part of line point intercept. So anyway, you get the idea. It's a pretty neat feature for managing the LPI form and cleaning it up. All right. So
quick question for you. Can you hear me?
Yes.
So on my screen, your windows are really tiny. I can't even read most of the text on there. Is there any chance you can zoom in?
So you should have the ability to zoom in on your screen with the features that you have as part of the web sharing.
On the upper right-hand side of the screen, there's a webcam zoom, and then you can change the % of your zoom right there.
Awesome. Thanks, Bailey. Okay. So once you've set up DIMA, there's some options in support tables where you want to load your master species list. You likely want to load ecological sites. And there may be some other data like states and counties and assigning what people will be interacting with the database. All of those are key setup things that I'm not going to review here, but know that those need to occur before you can go out to the field and successfully collect data using DIMA. So assuming that we've set up the database to our liking, we'll set up a new site, and I'll call this the demo site. And then from there, we can add plots to our site, and sites are groupings of plots. And so I'll select a new plot. It'll ask me how many transects am I going to do in that plot, and today we're going to do 3, and I'll say OK. And then this takes me into the plot description form, where items in bold are required to move on or close the page. So we'll call this plot demo 1. A quick note, if you're doing data entry in the field or in the office, DIMA defaults to the computer date when you create that form, and so if you're entering data from a previous date, be sure to change that. So in the plot description window, we can enter all of the information from the plot characterization and plot observation forms that are required as part of the covariates that we collect in EAM. And so on this general page, we add some state and county information, administrative unit, ecological site if known, directions to the plot, etc. We can also add the GPS information. Be sure that you are also taking a waypoint in addition to the GPS location that you're entering into DIMA, and that this reflects the actual location and not just the one that was given to you in your plot tracking Excel. You can enter the soil pit characterization that you do by adding a soil pit. You can add any disturbances or management history, but in fact, we'd actually prefer that you use the new plot observation form. And so in the plot observation, you select on that, and then we would create a new form. And then there's 4 tabs here that just take you through the plot observation form as it's built in the monitoring manual. And because these are long-term plots and we might go to sites multiple times, you have the opportunity to put in multiple sets of plot observation forms. So that's an option there. And then finally, species lists. when you're out at the field and you're about ready to start collecting data, the setting up a species list just as a draft working list is a really great way to make things go a little bit more efficiently. And so you might spend a little bit of time after you've set up the plot just looking around and noting what the dominant species are. Or if you're brand new to this and you don't know any species, you can also add sets of generic codes from which you'll identify the plots later. And so in here you can say, okay, how many different growth habits do I need generic codes for? How many sets do you need? Maybe, let's say 3. And then where do you want to start numbering from? Do you want to start numbering from 1, 2, 3, 4? And this will help us track unknown plants between crews who might be working in the same area. So let's say my crew has been assigned the 4s, and we'll just say okay. And so now my plot species list has been populated with some unknown plant codes that I'll be allowed to use moving forward into the season. Now, a quick note about unknown plant codes. Once an unknown code has been assigned to a given plant species, if that species is identified, then that code is retired. So for instance, if I say AFO4 is assigned to an annual forb, and that turns out to be a lepidium and I know what it is, I'll change the name of the species code to lepidium, but I'll never use AFO4 again because that only applies to that particular species. So that helps us track unknowns between plots and keeps the unknown plant data management a little bit cleaner. So again, this is all described in the monitoring manual under the plant identification section. All right. So moving on there, one quick thing that I will note is relative to unknown plants is if you go back to the main page and then select support tables, there is a new tab called generic species descriptions, and this is your unknown plant tracking list. And so you'll have all of the possible unknown codes that you might use for that season. And so I said annual forb. I can list the date that we found it. DIMA will automatically note any site or plots that are associated with it. We can provide comments and then any other observations. And we can maintain these details and fill out a form that helps us track that unknown and particularly important features of that unknown. And then once we identify it and it's changed in DIMA, DIMA actually will note that automatically as well. So this is a great new feature for tracking your unknowns. There's also a data sheet at the back of the monitoring manual if you prefer to do that on paper. All right. So really quickly, let's go over a little bit of data entry. So once I've set up the plot, good to go there. I might want to go and enter some data. And so I would select the method that I want to do. So I'm going to do line point intercept. I'll create a new form. All of these defaults that we set up are still here, which is great, but it's always good to double check. And then we can go and start collecting data. Now there's a little bit of metadata that DIMA requires us to enter, for instance, the line number, who the recorder is, which we haven't set up in this database, and who the observer is. And from here, generally people prefer to use the quick data entry form. It tends to be a little bit faster. And this is your basic line point intercept form where you select the top hit, any lower codes, as well as the soil surface code. And so once you've done that, you move to the next pin drop and go through it again. And for those of you who have done DIMA, used DIMA before, you'll notice that these lower code lists are much shorter because we've pared down the number of possible codes that can be used here. The other neat thing about DIMA is that there's a same as last button right here. So if you're hitting, say, none bare ground or bare soil over and over and over again, you can hit same as last and move to the next point. So that saves you a little bit of time on data entry. So now we're at position 2.5, which is a height measurement position. So DIMA will not let us move forward until we have measured the heights of the tallest woody and the tallest herbaceous species. So if I tried to go next, DIMA would say, warning, woody or herbaceous height is missing. So I say, okay, whoops, I've got to go back and actually enter that information and do height. And so in this case, maybe my tallest shrub is standing dead, that part of it, and let's say it's 56 centimeters. And then my tallest forb is an annual grass. It's still alive, and we'll say that that's 12 centimeters. And then I can move forward. And so there's some nice error checking features of DIMA that kind of save you from yourself, which is always handy. All right. Are there any questions?
Oh, okay. Yeah.
Yeah, so I use DIMA a lot.
Oh, okay. Yeah, I was just trying to do.
I have had to mute everybody, so if you have a question, please do be sure to chat me or something. Cool. All right, so that is a brief overview of line point intercept. Hopefully you've had a chance on the homeworks to interact with that a little bit. So are there any questions about LPI from the homework? Cool. So I haven't done entered all of the data for this form, and DIMA is catching that, which is good. And if I was in the field, I'd want to go back and make sure I'd collected all data at every point in which I was supposed to. So from there, we can move on to GAP and do a GAP form and collect data similarly to how we did with line point intercept. We note which plants stop a gap, which for AIM is everything except for other. And then from there, we can note the starts and ends of gaps. Again, DIMA's got some nice error checking features where if our minimum gap size is 20 centimeters, which is the standard for AIM, and we put in a gap that is less than 20 centimeters, we'll get a notification that the gap is below the minimum and that that's a problem. And so at that point, you can go back and say, okay, was that gap actually too short, or did we like misenter the data? In the case of having no gaps at all, you can check that button to indicate that you went and you looked, but there was nothing there. So that is gap. Soil stability, if you choose to do it, also is very similar to in setup structure as the LPI and GAP forms. And from there, it's exactly like the data sheet. You note the position and line on which you collected the data, and then the final ranking. A quick note, there's lots of help tabs scattered throughout the DIMA forms, and so if you forget what some of the rating values meant or just need some extra help, that's actually embedded into DIMA, and that can be of greater assistance, although we always recommend going to the monitoring manual. All right. So that is soil stability and species richness. Again, all of the defaults are what we set it up to be before. And you have your basic metadata that you need to set up before you can even start entering data. And a cool thing about species richness is it'll actually port the data from LPI. So if there are species that you detected during LPI, it'll pull those over as well and then enable you to walk around for 15 minutes detecting new species. Now, another new aspect of the method this year is that if you're still detecting new species at the end of that 15-minute period, feel free to keep looking until you haven't detected a new species for 2 minutes. And we'll go over that a little bit more in the training. All right, so that is, okay, so we've had a question. Can you add a new code through the species richness form? Yes, that is a great question. Let's go back into that form. You can do this on both species richness and line point intercept. So let's say I get on species richness and I'm like, oh, this is a really, this isn't a very common plant on this plot and I didn't see it when I built that species list. You go to edit plot species and we're back in that plot description species list form. And from there you can either add a species from the master species list if you had loaded it, or you can add another generic code if you need to. So let's say we add cheatgrass, and it's listed here, and we close and we go back to the species richness form, and it is right there, except we need to unlock it, and we can add it to our list. So quick note that this list over here on the left is what is actually being recorded. These lists here are just possible species that you might encounter, and they may or may not actually exist there by the end of the day. So we view this as a scratch workspace and not a final workspace, whereas this box on the left here is the final workspace. Great. Any other questions? Were there any questions that came up from the homework? All right, so once you've collected data, there might be some data cleanup things that you want to do. For instance, you might have identified what some of those unknown plant codes were, and so you can actually go and update that within DIMA by going to administrative functions, and then data management, and then mass update of a species code. And you have the option to mass update codes site by site and plot at a time, or to do it for the entirety of the database, which is also a new feature, which works really well. So let's say we have identified AFO4, and that's a lepu now. And we can do this for all sites. And then it'll tell us how many LPI forms were changed, how many species richness forms were changed. So this is a really useful tool that I imagine most field crews will end up using quite frequently throughout the season. The other tool that you have available to you is running reports. And these reports allow you to check the data both while you're at the plot and then also back at the office. So again, you select the site and plot that you might want to run a report on, and you can run a line point intercept or a gap report. You can also run some reports looking at the plot definition information, as well as species reports are good for detecting how many unknown species you have in the general species list that you've been working off of for the season. So you run the report. For LPI, we really recommend the indicators report. The comprehensive report really hasn't been supported for a long time, and so there may be some errors within that report if you're noting discrepancies between the two reports. So let's look at total foliar. There's a lot of indicators that you can look at. Let's look at total foliar and run that report. So it'll pop up an Excel workbook that has some metadata information, any species that were used in calculating that report, the indicators that were run to create that report, and then site totals, line totals, etc., as well as calculation details. So if you want to know what DIMA is doing in the background, that's an option.
Sarah, may I ask a question?
Sure.
Is there a way in the DIMA, if you've already entered data in Excel, to import those Excel forms directly into the DIMA?
Yes. And that may be a question that I can talk with you more about at a later date, but essentially with DIMA, when you download it from the Jornada, you'll get a bunch of files that look like this, where you have a county folder, GPS tools, and import templates, and those are the Excel templates. And so these, if you can get your data into the format of the LPI form, let's say you want to look at LPI data, so long as you can get your data into that structure, then there's an ingest option in importing data in DIMA to pull it all through. Good question. Anything else? All right, so we've mostly been talking about plot level data and the actual monitoring data that you collect using DIMA, but there's another critical piece of data management and managing AIM data, and that is the sample design. And the sample design is what tells you where in the landscape you're actually going to go, and then at that point, once you get there, that's when DIMA kicks in. And so Sarah Burnett wanted to take a couple minutes to give a little bit of an overview of how these points are picked, as well as the data management aspects of dealing with these plot locations. So Sarah, if you're ready, do you need the screen?
I would take the screen. Can you hear me?
All right. Yeah.
Okay. All right. Can you all see my screen now? I'm gonna hope that is a yes. No one said no. So the thing that I wanted to talk about was, one of the things is plot tracking Excel. So along with your sample design shapefile, when you get the final design from your project lead, you'll get a plot tracking Excel, which should look something like this. This is an example from Idaho, from the Bruno field office. And I just want to go over with you guys some of the things to kind of watch out for, some of the common mistakes that we saw last year with this. One is just that every plot given to you, even your oversamples, need to get a plot status. So as you're going through and rejecting, you'll do office rejections and then field rejections. You should be noting that in here and putting rejected, and then going over into the section for rejection and noting why you rejected it, whether it was in the office or the field and what reason, as well as any additional comments. If you did go ahead and sample it, you can put sampled, and then there's some more information to put in on the very right-hand side of the document. So this information will be things like, if you're figuring out the ecological site, you can put that in the actual stratum, what project the plot was associated with, if it is a half plot or just a normal terrestrial AIM plot, and then if it was random or targeted. And if you have any confusion on what to put in these columns, you can go ahead and consult your project lead. If you know it was a revisit, we'd like the original plot ID and the original date if you have it. If you implemented the move protocol, we'd like to know that, and then some comments about which direction you moved it. We'd like to know the date visited, and then the actual latitude and actual longitude is one area of some common where people get this wrong. And so what we're asking for is that you guys as the crew when you go to the location for your plot, you're going to take a waypoint, usually with your GPS, and then you're going to type that waypoint into DIMA, usually on the field. What we'd like you to do for the plot tracking Excel is to actually go back to your GPS unit and use that to type in the latitude and longitude into this form. One of the reasons being is that entering incorrect GPS coordinates is a common error in DIMA, and because you're just manually entering a bunch of numbers, it's really easy to get wrong. And so we like to use this form as a backup so we don't have to come to you and say, hey, that plot location was wrong, do you know where it was? So there's no guesswork. So if you could just actually go back to your GPS unit to fill these fields out, that would be amazing. You can also put not sampled, so a lot of your oversamples will get not sampled. Another thing is that we'd like to have every plot you visit or draw entered into the plot tracking Excel. So every plot that comes to us in the DIMA should have associated plot in a plot tracking Excel. So if your project lead is drawing plots using Shiny or giving you targeted plots, they won't come pre-populated in the Excel form, so you're going to have to enter them in. Just give us the exact plot ID that is entered in DIMA so we can track the two. So that's another common mistake we've seen. This plot ID should be exact, so we need the exact dashes or underscores, the full name, not just the last 3-digit number in DIMA. So we want what is in this plot tracking Excel to match exactly what's in DIMA, to match exactly what's in the sample design shapefile so that there's no confusion and we can track those and join those in ARC and everything. So this is the plot tracking Excel. It's a pretty important part of data management. There's more information on the website, and with the final designs is the data management protocol. You should all either have seen this now or we'll see this at training. It talks about the plot tracking Excel and has some plot tracking Excel documentation in one of the appendices. So please give this a look. If you have any questions about what should be in the field, consult this first. It's got some good information. So the other thing I wanted to talk about was how to implement your sample design. So if you go to the website and you go under data collection to sample design and trip planning, there is down here some kind of rules of the road for how to implement a sample design. And you guys will be given, if you're going to training, you'll be given a bigger presentation in that training, but I just kind of wanted to highlight some of the things you're going to be hearing here because they're kind of a lot, and I wanted to make sure you guys knew where to go on the website to be looking at this information so you can kind of have a little bit before you go. So there's kind of two rules to keep in mind as you're implementing the sample design. So when you're given a sample design, the plots will have an ordering to them. They'll be numbered, and so one of the general rules for implementing a sample design is that you visit the plots in order. So for instance, here in this example, there are two strata. We have forest and shrubland. Forest goes from 1 to 10. Shrubland goes from 11 to 25, I believe. So for forest, we really would like you to go, we don't want to see you sample plot 1 and 5 and then not sample plots 2, 3, and 4. The other kind of general rule is that you should be throughout the season keeping track of the proportion of plots in each strata and trying to mirror that. So if 50% of your plots are in one strata, as you're going throughout the season, you really should be trying to hit 50% of your plots in that strata. So that's a lot, and there's some things you can do to make it more efficient. You can you know, take a subsample of your plots that you know you're going to sample, and within those you can kind of make sure that you're being efficient and hitting them in a location, you know, making sure your hitches are close together and so you're not traveling across the field office. And so that's called bet hedging, and we'll talk about that more in detail at the trainings, but just kind of wanted to give you some general things to keep in mind. This is an example of what can go wrong if you don't go in order. You're going to miss some of the spatial balance, and kind of you could aggregate all your plots on one side of the field office, which can really introduce some issues if there is some differences in rainfall between years. So just look at this example, go to the website, spend some time with this, go to training, and if you still have any questions, feel free to contact either the NOC or Jornada, and we can give you some more information. The only other thing I wanted to talk to you about is missing data. So Sarah was going through DIMA and showing you how to enter everything in. If everything at a plot goes perfectly, every one of those forms will be filled out completely. However, we know that's not always the case. So we give you on the website, and with each design, we're giving you a template for how to document missing data and known errors. We're trying to get away from the idea that every data set is perfect. The thing that can make it perfect is that if you track everything that goes wrong. So for instance, if you are missing one line of LPI because your tablet shut off and you ran out of paper, or you lost your paper data sheet on your way back, we need to know that in this form, and then we won't be coming to you at the end of the season and saying, hey, where's that line of LPI data? We'll just know it because it's documented in this form. So be filling this out throughout the season, and everything should be good. So I think that's all I had, Sarah, if there are any questions about any of this stuff I just went over. If not, I'll pass it back to you, Sarah McCord.
Okay, sounds good. I think with that, that is our webinar. I am going to put the contact information up again on the screen, so feel free to contact us at any point in time if you have questions. Hopefully we'll see many of you at the training starting next week, and we look forward to seeing some awesome data come from you guys. So thank you all for attending, and hope you have a good afternoon.